Stray voltage refers to unwanted, low-level electrical voltage present in locations or objects where it is not intended. It is typically caused by current leaking from power lines, electrical appliances, or wiring systems. Stray voltage can originate from various sources. Firstly, transformer imbalances can create stray voltage in nearby structures when current imbalances occur in electrical transformers. Secondly, faulty wiring, specifically improperly installed or damaged wiring, can allow current to leak into the ground or other conductive paths. Thirdly, appliance malfunctions involving faulty appliances or devices with exposed electrical components can release stray voltage. Fourthly, current flowing through overhead power lines can induce stray voltage in nearby objects, such as metal fences or buildings. Stray voltage cannot be used to power devices. Stray voltage is typically very low, usually ranging from a few millivolts to a few volts. It is not sufficient to light a light bulb or run a motor. The low voltage and intermittent nature of stray voltage also make it unreliable and impractical for use in electrical devices. The electrical systems are designed to contain electrical current within designated pathways, ensuring safe and efficient operation. Stray voltage deviates from this design, representing unintended voltage that appears on conductive surfaces or in areas where it shouldn't be present. The presence of stray voltage can pose several concerns, ranging from nuisance shocks to potential safety hazards for both humans and animals. Understanding the sources and characteristics of stray voltage is essential for effective identification, mitigation, and prevention. Electrical codes and standards, such as those outlined by the National Electrical Code, or NEC, provide guidelines for proper wiring practices, grounding techniques, and equipment installation to minimize the risk of stray voltage. Regular inspections and maintenance of electrical systems can help detect and address potential sources of stray voltage before they escalate into significant problems. Furthermore, utilizing appropriate grounding and bonding methods can provide alternative pathways for stray current to flow back to its source, reducing the voltage potential on exposed conductive surfaces. Mitigation strategies for stray voltage may involve isolating the source of the leakage, improving insulation, implementing equipotential planes, or employing specialized grounding techniques. In agricultural settings, where animals may be particularly susceptible to stray voltage, measures such as installing equipotential grounding systems in livestock areas can help minimize the risk of electric shock. Additionally, ensuring proper wiring and grounding of electrical equipment used in agricultural operations can prevent stray voltage from reaching livestock. The detection of stray voltage often requires the use of specialized testing equipment, such as voltage detectors or multimeters capable of measuring low-level voltage. Qualified electricians or electrical inspectors can conduct thorough assessments to identify the source and extent of stray voltage in a given environment. It is important to distinguish stray voltage from normal operating voltage in electrical systems. Normal operating voltage is the intended voltage that powers electrical devices and equipment, while stray voltage is unintended and typically much lower in magnitude. Stray voltage can fluctuate depending on various factors, including the load on the electrical system, the proximity to power lines, and the conductivity of the surrounding environment. In some cases, stray voltage may be intermittent, appearing only under certain conditions or at specific times. When investigating stray voltage complaints, it is crucial to gather detailed information about the location, time of occurrence, and any associated symptoms or observations. This information can help narrow down the potential sources of stray voltage and guide the troubleshooting process. In addition to addressing the immediate source of stray voltage, it is also important to consider the overall integrity and safety of the electrical system. This may involve upgrading wiring, replacing faulty equipment, or implementing additional safety measures to prevent future occurrences of stray voltage. Public awareness and education play a vital role in reducing the risk of stray voltage incidents. Informing individuals about the potential hazards of stray voltage and providing guidance on how to identify and report suspected cases can help prevent accidents and injuries. Furthermore, promoting responsible electrical practices, such as avoiding contact with exposed electrical components and using ground fault circuit interrupters, or GFCIs, in wet or damp locations can minimize the risk of electric shock. In summary, stray voltage is an unintended electrical phenomenon that can arise from various sources, posing potential safety hazards. Understanding the causes, characteristics, and mitigation strategies for stray voltage is essential for ensuring the safety and reliability of electrical systems. By implementing proper wiring practices, grounding techniques, and maintenance procedures, the risk of stray voltage can be minimized, protecting both people and property from electrical hazard. Furthermore, public awareness and education can contribute to a safer electrical environment for everyone. Current imbalances in electrical transformers can lead to stray voltage due to uneven distribution of current flow within the transformer windings. This imbalance can result in a voltage potential between the transformer's grounded neutral and nearby conductive objects, such as metal enclosures or grounding electrodes. The magnitude of stray voltage caused by transformer imbalances can vary depending on the severity of the imbalance and the proximity to the transformer. Faulty wiring can introduce stray voltage by creating unintended conductive paths for current to flow. Damaged insulation, loose connections, or improper grounding can all contribute to current leakage, resulting in stray voltage on nearby conductive surfaces. The severity of stray voltage caused by faulty wiring depends on the extent of the damage and the conductivity of the surrounding materials. Appliance malfunctions can release stray voltage when internal components fail or insulation degrades, allowing current to escape from the appliance's intended circuitry. This stray voltage can then be present on the appliance's enclosure or any conductive surfaces in contact with the appliance. Over time, the cumulative effect of stray voltage exposure can lead to corrosion, equipment damage, and increased risk of electrical shock. Regular inspections and maintenance of appliances can help identify and address potential sources of stray voltage. Overhead power lines can induce stray voltage in nearby objects through electromagnetic induction. The alternating current flowing through the power lines creates a magnetic field that can induce a voltage in conductive objects, such as metal fences, buildings, or buried pipelines. The magnitude of the induced voltage depends on the proximity to the power lines, the current flowing through the lines, and the conductivity of the object. Grounding and bonding techniques play a crucial role in mitigating stray voltage by providing a low impedance path for stray current to flow back to its source. Proper grounding ensures that conductive objects are connected to the earth, minimizing the voltage potential between them and the surrounding ground. Bonding involves connecting conductive objects together to create an equipotential plane, reducing the risk of electrical shock. Equipotential planes are especially important in areas where livestock or people may come into contact with multiple conductive surfaces simultaneously. Ground fault circuit interrupters, or GFCIs, are designed to detect small imbalances in current flow and quickly disconnect power to prevent electrical shock. GFCIs are commonly used in wet or damp locations such as bathrooms, kitchens, and outdoor areas, where the risk of electric shock is higher. Regular testing of GFCIs is essential to ensure that they are functioning properly. Isolation transformers can be used to isolate electrical equipment from the main power supply, preventing stray voltage from propagating through the electrical system. Isolation transformers provide a high degree of electrical isolation between the primary and secondary windings, minimizing the risk of ground loops and stray voltage. Specialized testing equipment, such as voltage detectors and multimeters, is used to detect and measure stray voltage. Voltage detectors are non-contact devices that can detect the presence of voltage without physically touching the conductor. Multimeters can measure both alternating current, or AC, and direct current, or DC voltage, as well as resistance and current. When investigating stray voltage complaints, it is important to follow a systematic approach to identify the source of the problem. Firstly, gather information about the location, time of occurrence, and any associated symptoms. Secondly, inspect the electrical system for any obvious signs of damage or faulty wiring. Thirdly, use appropriate testing equipment to measure voltage levels at various points in the system. Fourthly, analyze the data to determine the source of the stray voltage. Fifthly, implement corrective actions to eliminate the stray voltage and prevent future occurrences. In agricultural settings, stray voltage can pose a significant threat to livestock. Animals exposed to stray voltage may exhibit symptoms such as reduced milk production, decreased appetite, and behavioral changes. Equipotential grounding systems are commonly used in livestock areas to minimize the risk of electric shock. These systems consist of a network of interconnected grounding conductors that create an equipotential plane, ensuring that all conductive surfaces are at the same voltage potential. Regular testing and maintenance of equipotential grounding systems are essential to ensure that they are functioning properly. Public awareness and education are crucial for preventing stray voltage incidents. Informing individuals about the potential hazards of stray voltage and providing guidance on how to identify and report suspected cases can help prevent accidents and injuries. Promoting responsible electrical practices, such as avoiding contact with exposed electrical components and using GFCIs in wet or damp locations, can minimize the risk of electric shock. Electrical codes and standards, such as the National Electrical Code (ONEC), provide guidelines for proper wiring practices, grounding techniques, and equipment installation to minimize the risk of stray voltage. Compliance with these codes and standards is essential for ensuring the safety and reliability of electrical systems. Regular inspections and maintenance of electrical systems can help detect and address potential sources of stray voltage before they escalate into significant problems. Qualified electricians or electrical inspectors can conduct thorough assessments to identify and mitigate stray voltage risks. Mitigation strategies for stray voltage may involve isolating the source of the leakage, improving insulation, implementing equipotential planes, or employing specialized grounding techniques. The specific mitigation strategy will depend on the source and severity of the stray voltage problem. In some cases, it may be necessary to consult with electrical engineering experts to develop a comprehensive stray voltage mitigation plan. Stray voltage is a complex phenomenon that can arise from various sources. Understanding the causes, characteristics, and mitigation strategies for stray voltage is essential for ensuring the safety and reliability of electrical systems. By implementing proper wiring practices, grounding techniques, and maintenance procedures, the risk of stray voltage can be minimized, protecting both people and property from electrical hazards. Furthermore, public awareness and education can contribute to a safer electrical environment for everyone. When dealing with electrical issues, it's always recommended to consult with a qualified electrician to ensure safety and compliance with electrical codes.